My name is Dr. Sandeep Kunar, and Assistant Professor of Aditya Engineering College in Mechanical Department. Okay. Today I will discuss about the lecture about casting process. It is under Unit 1. And end of this lecture, student will able to learn introduction to casting and requirements of the casting process and steps involved in making the casting and advantages of casting and its applications. First is foundry and casting. What is foundry? The place where we have done the casting process, that place is called foundry. The place where we perform the casting process, that place is called foundry shop. Then what is casting? Casting is a manufacturing process by which we produce the casting product. What happens in that process? Now, in mold cavity, we pour the molten metal. After pouring the molten metal, that product will convert it into solidified casting product. Okay, means what happens? Now, that manufacturing process by which we pour the molten and liquid metal into the mold cavity. Okay, and that mold cavity is prepared by a particular desired shape. After coming the molten metal to the particular desired mold cavity, the molten metal, it will take the particular shape, and after sometimes it will convert it into solidified product. After solidification, finally we have taken the casting product from the mold cavity after broken the molding materials. The solid casting is then taken out and cleaned to complete the process for getting the final casting product. Now, different casting terminology are available for the casting process. What are the main terminology for the casting processes? First is pattern. Means that is the approximate replica of the produced shape. Approximate duplicate of the part to be cast means that it is a part of the casting process. Using that part, we produce the particular desired shape to the mold cavity. Okay, and another is molding material. Material that is packed around the mold cavity. Means that molding material is kept to the flux, means that is called molding box or it is called rigid frame. Okay, that is the molding material. Another is the flux. Flux means that is the rigid frame of the casting, means that is called molding box. Okay, in that molding box we pour the molding material and also kept the pattern and produce the particular cavity shape. That is the flux. Cope. Cope means top half part of the pattern, means top part of the molding box, that is called cope. Top part of the molding box, that is called cope. Then drag, that is the bottom half of the pattern, means bottom half of the molding box, that is the drag. Means if we are taken that is a molding box, if we consider that is a molding box and that is the meeting line, that is the parting line, it is called parting line. It is called parting line. It is called parting line. The upper part is called cope, lower part is called drag. Core material is a made of sand material. Actually, that thing will be used for generation of internal features. Okay, that is the core material. Okay, then another is core print. It is a open access space provided in the mold for locating, positioning and supporting the core. Okay, that is the core print. Core print mainly used for positioning, supporting and locating the core. That's why we use the core print. Core is used for producing the internal shape to the particular casting product. Another, mold cavity. Mold cavity means combination of the mold material and cores. Means that mold cavity has been prepared as per replica of the pattern, and in that mold cavity we pour the molten material, and after sometimes it will take the particular solidified shape. That is the mold cavity. Riser acting as a molten material reservoir. Means what happens now, additional void we have prepared in the casting process, and due to additional void, when the molten material comes to the mold cavity, it after sometimes it will solidify. After solidification, some voids will be created. Some void will be created, means some shrinkage. Due to shrinkage, some void will be created, and due to that void creation, the additional molten material come to that particular mold cavity for filling up that voids. That is the use of riser. Means riser used as a reservoir, or it is the additional void which will be used for storing the molten material. When it will send? When the shrinkage will be taken to the mold cavity, the void will be created, and for compensation to that particular mold cavity, the extra material comes from reservoir to that particular shrinkage voids. Another is gating system. Gating system means that is the network of channels that delivers the molten material to the mold. Means in that gating system, number of parts are there, and through that gating system, the pouring molten metal is come from pouring basin to that particular mold cavity. Means that is the network of channels through which we send the molten material to the particular mold cavity. That is the gating system. And pouring cup. Pouring cup means pouring basin through which we pour the molten material to the from the ladle, and from that pouring cup or pouring basin, the molten material comes to the particular mold cavity. That is the pouring cup. Another sprue, that is the vertical portion of the gating system. Sprue means that is the vertical portion of the gating system, means vertical portion. And runner is, that is sprue vertical portion, and in case of runner, that is the horizontal channels. And another gates means control entrance. Means molten material from the pouring cup through the gates, it will come to the mold cavity. Means that is the control entrance. It will control the flow of molten material to the mold cavity. Another, parting line. What is parting line? Means the middle line in between cope and drag. Means that is the parting line. That is the parting line of the molding box. That is called flax. Means that also molding box. Actually, it is rigid frame. That is called also flax. Means the line lie between cope and drag. That is called parting line. That is called parting line. Draft means sometimes in pattern we provided some angle or taper section for easy removal of the pattern from the mold cavity or from the molding box. That taper or angle section we have provided to the pattern that allow for easy removal of the casting from the mold. Means that draft or angle we have provided to the particular pattern, and due to providing that shape, easily we have removed from the mold cavity. Casting, already I have told, casting means describe both the process and product where molten material is poured to the mold cavity and then it is solidified. Finally, we have got the casting product. Means if we consider that is a flax, upper part is cope and lower part is drag, and middle line is called parting line. Also it is called cheek. Okay, and sometimes the supporting, if we consider that is the core middle line, that is the parting line, if we consider that is the core, some extra space or extra supporting materials we have used for positioning, locating and supporting the core, that is called core print. It is called core print for supporting the cores and positioning and locating. Okay, that is called core box. Okay, and that is called core. Core is used for producing the internal features to the casting product. If that is the cross section of a mold, if we consider that is a flux, or that is a rigid frame, or it is called rigid, that is the rigid. It is called molding box. Also it is called flux. Okay, and in that molding box, the upper part is called cope, lower part is called drag. Okay, and that is the mold cavity. That is the mold cavity that is prepared as per pattern shape. As per pattern shape, we have produced the mold cavity. Okay, that is the mold cavity. Mold cavity is prepared as per pattern shape. The internal part, that is called core. Core is used for producing the internal shape to the mold cavity. As per core shape, the internal features will be prepared. That is called core. And for supporting the core, the core print we have used for supporting, locating and positioning purpose. We have used the core print, and that is the some pins we have used for connecting the upper part and lower part to that particular molding box, and that is the horizontal section, that is called runner. Okay, and the middle line, that is called parting line. The middle line, that is called parting line. That is called parting line. And the horizontal section, that is called sprue, and that is called sprue oil. That is called sprue oil. That is called sprue oil, and that is the pouring cup, or it is called pouring, or it is called pouring basin, or it is called pouring basin. So that are the, and in that pictures we have shown some angle or taper section we have provided to that particular molding cavity, means it is called drape, means easily we have removed the pattern from the molding box. That is the some characteristics, some components of the gating system. What are the requirements in case of casting? First is mold cavity is prepared as per pattern shape, means as per desired shape we have prepared the pattern, and as per pattern we prepare the mold cavity, means mold cavity with desired shape and size. Mold cavity is prepared as per desired shape and size. Second is melting process to provide the molten material, means what happens now, first then we produce the molten material using some metal pellets, means it will, molten material is prepared to the particular furnace, maybe in any furnace we have prepared the molten material, then that molten material is poured to the mold cavity for producing the casting product. Third is pouring process, introduce the metal into the mold, means after preparing the molten material then we pour the molten material, means after preparing the molten material we pouring the molten material to the pouring basin. After pouring the molten material to the pouring basin, throw sprue, runner it will come to the particular mold cavity. Okay, that is the entrance, means that is called gates. That is called gates of the gating system. Means that is the entrance, called control entrance of the gating system, and it is called riser. It is called riser. Riser means it is acting as a reservoir. Means when the solid means shrinkage will be taken to the mold cavity, some extra voids will be created, and due to creation of extra void to that particular mold cavity, for compensation, for filling up that mold cavity, the material will come from riser to that particular mold cavity. Okay, that is the use of riser. Another, after pouring the molten material to the mold cavity, then it will take the solidification, directional solidification process, and control prevent defects. Means when pouring the molten material, then the heat will be extracted from the mold cavity. Okay, first the heat will be extracted from the surface. After extraction of the heat from the surface, then it will start the solidification. Means solidification start from surface towards the center. Okay, means fourth one is solidification process, and fifth one, ability to remove the casting from the mold. Means after solidification, we broken the molding box, means we separate the cope and drag frame. After separation, then we remove the molding materials, means sand, some other additives, then we remove. After removing that parts, then we remove the pattern. After removal of the pattern, finally we get the particular desired shape as per replica shape of the pattern. Okay, and last one, cleaning and finishing and inspection devices. Means after producing the casting product, then we finish the outer surface of the casting product. Then we do the finishing. Finishing means if some extra bars or extra some impurities is added to that casting product, then we have removed by some grinding or turning process, some machining process. Means we finally take the finishing process, and then inspection. Means as per required dimension, the product will be prepared or not, then that will we have inspected. 6 basic steps of the castings. What are the basic steps? First is mold cavity is produced having the desired shape and size. Means mold cavity is prepared as per pattern shape. Okay, means that will be prepared as per pattern shape and size. What means in that cases, what happens now, takes shrinkage into the account. Means after solidification, the molten material will be shrinkage. Okay, so using that point, we consider the shape and size of the part as per considering the shrinkage point. Okay, means it will, after solidification, it will shrinkage. Okay, so due to shrinkage, we also does not get the proper dimension. So using that point, we prepare the particular cavity shape. If we prepare that particular cavity shape, if we get extra dimension in that particular mold cavity, so the product will be prepared as per required shape. Then single use or permanent mold. Sometimes if we take so many joints in the pattern, so during removal or during separation of the molding box, sometimes the pattern casting product may be defected. Okay, so we avoid the number of joints to the pattern. We try to take particular single use or permanent mold we want to use for the particular preparation of the mold cavity shape. Another is melting process. Means what happens in case of melting process? Now provides the molten material at the proper temperature. First particular temperature we prepare the molten material, okay, to the furnace. And third is pouring technique. Means in the casting process, through using gating system, we pouring the molten material through pouring cup, sprue well is there runner. Through that network, means network of the gating system, from pouring cup it will come to the mole cavity, and it will take the particular shape of the cavity shape. Okay, and sometimes when pouring the molten material, maybe due to turbulence of the molten material, maybe erosion takes place, maybe some defects will be created to the pouring cup. So we have taken care about that thing when we pouring the molten material to the getting system. Fourth one, solidification process. After pouring the molten material to the getting system, so after coming the molten material to the particular mole cavity, after coming to the particular mole cavity, means if we consider the molten material comes to the particular mole cavity, so after coming the molten material to that particular mole cavity, what happens? To certain times it will take solidification. Okay, and then it will take the particular shape as per mole cavity shape. Okay, and after solidification it will take shrinkage, means it will create extra voids. Okay, for filling up the extra voids, extra materials come from riser. Means what happens, if we see that picture, after creation of the particular mole cavity shape, what happens, it will take the particular shape as per mole cavity shape. After solidification, what happens, means if we consider that is the mole cavity shape, after solidification that type of shape will be created. Okay, means extra voids will be created, extra voids will be created. For filling up of these extra voids, that is the extra voids, that is the extra voids. For filling up the extra voids, the extra materials come from riser and filling up that voids, and filling up that void. Then again it will take solidification and the particular shape will be produced as per cavity shape. After that, mold removal. Mold removal means after solidification process, finally we have taken the casting product. After removal of the cope and drag part, then we remove the pattern and also remove the pattern material. After removal of that parts, finally we have got the particular cast product. Means as it is prepared as per shape of the mole cavity. And finally cleaning, finishing and inspection operations. Means after preparation of the mold casting product, then we clean the outer surface. After cleaning, then maybe some bars, some maybe depression will be created to the cast product. So we using some machining operation, conventional machining operation or some other machining operation, we finish the outer surface and finally inspected, means the dimension is accurate, the shape is accurate or not. In case of during solidification times, what happens? Now molten material comes to the mole cavity and it will prepare as per mole cavity shape. Okay, some casting defects may be created during solidification process. Means gas porosity. Gas porosity means when molten material comes to the mole cavity, means when mole cavity contact to the mole surface, at that time sometimes the gas will be created, means some vapors will be created, and due to creation of the vapors, that type of gas will be stored to that particular mole cavity. Okay, and due to trap of the gas to that particular mole cavity, some voids will be created and they want to come out from that particular mole cavity. If they will get some track, then they will come out. Otherwise, if the gas will trap to that particular mole cavity, then some pores or some defective product will be created. Okay, so that gas porosity, it is must necessary to remove the gas porosity problems. Okay, how to solve this problem? By adding the vent. Means some rod type components is there, using that thing we remove the gas, means that is called venting operation. Another is shrinkage. How to solve this problem? Means shrinkage means when solidification takes place, the shrinkage will be taken to that particular mole cavity. So for that cases, what happens? Solve by using the riser to at the molten metals. Means already I have told riser acting as a reservoir. When shrinkage will take place to the mole cavity, so at that time we send the extra material from the riser to the mole cavity. Means after that, means already I have shown that if it is the mole cavity, means some after solidification some extra voids will be created to that, means that is the extra voids. Extra void means extra space will be created, and for filling up that extra voids, the extra materials come from riser and filling up that voids, and particular shape will be produced as per mole cavity. How the molten material takes solidification to the particular mole cavity? Two process. Another is nucleation, second is growth. One picture I have taken, means if we consider that is the molding box, that is called flask. Okay, and that is the pattern shape, and that is the gating system. That is the gating system. It is called pouring cup. That is called pouring cup. Okay. So what happens when we pour the molten metal through the pouring basin? It will come to the particular mole cavity. It will come to the particular mole cavity. Okay. Means it will take the particular shape as per mole cavity shape. Okay. Then the solidification will start from that surface. Means when molten metal comes to that particular surface, the first heat will be extracted from the mole through mole surface. It means heat extraction will be start from that particular mole surface and take the solidification from that particular surface. Solidification will start from that surface area, because in that surface the first heat extraction will be started. Means solidification starting from surface towards the center. Okay, then it will take the solidification as per shape, and finally that product will be produced. That is the final product. Okay. Nucleation means that is the process of the solidification of the molten material to the casting. First, what happens? Stable particles form from the liquid metals. Means we pour the molten material, then after heat extraction the stable particles, means grains formation started to that particular mole cavity. Okay, occurs when it will occurs when there is a net release of the energy from the liquid. We know, means heat will be released. Heat is a one type of energy. Means net release of the energy. Net release of the energy means heat will be released. Heat will be removed from the molten material through the mole surface. Means occurs when there is a net release of the energy, means net release of the heat from the mole surface. Okay, from the mole surface, through the mole surface from the liquid. Liquid means from the molten material. What is called undercooling? Undercooling means difference between melting point and the temperature at which the nucleation will start. Means it will start the solidification process. Means start the nucleation process. Means stable particles will be formed. Just start the formation of the grain particle. Okay. Each nucleation event produces a grain. Means each nucleation means start the nucleation process from surface towards center. Means every surface around every surface it will take solidification around the whole surface. First from the throughout the surface, mole surface, it will take the solidification and it will come towards the center. Means nucleation is promoted more grains. Means each starting of the nucleation means each grains will be formed, and due to formation of each grains, then it will promoted to more formation of the more grains. Formation of the more grains means for enhanced material properties. Due to formation of the more grains, the material properties will be improved or material properties will be enhanced. And another is grain refinement, means each grain will be formed, then each grain again it is combined, means grain refinement it is continuing. It is the process of introducing solid particles to promote the nucleations. Means due to formation of the each grain, it will continuously form more and more grains and it will produce the solid product. Means that process is called nucleation. Grain growth. Grain growth, when it will be occur, means the heat fusion is extracted from the liquid. Means grain growth means more and more grains will be formed to that particular mold cavity. Means when it will occur, means when heat will be extracted from the liquid. More and more heat will be extracted from the liquid. Then more and more grains will be formed and finally it will produce the solidified product. And direction, rate of heat extraction and another type of growth, grain growth, that can be, we have control as per using the particular characteristics to the casting process. Means heat extraction, means directional solidification, that depends upon the one component that is called chilled. Directional solidification to the casting process is controlled by the using chill. Some other components is there, using that components we control the direction, rate and type of growth can be controlled. And control by the way in which heat is removed, means removal of the heat, that is also control the solidification. Means directional solidification means solidification is start from mold surface towards the center. Okay. So due to that cause, the solidification start from, means control by the way in which heat is removed. By the way means heat will be removed from the surface, and due to removal of the heat from the surface, the solidification start from mold surface. Means control by the way in which the, means what happens now, heat will be removed from the mold surface first, and due to heat extraction from the mold surface, the solidification start from that points. Solidification start from that points, means it will start from that particular surface and comes towards the surface, and totally finally it will produce that type of solidified product. Okay. Another is rates of nucleation and growth control size and shape of the crystal. Means more and more grains will be formed, then grain refinement is taking place, then the growth means growth control, means grain growth control, that also control the formation of the crystals. Means after more and more grains combined and then finally it will produce the crystal shape, means produce the crystal, maybe crystalline shape, maybe non-crystalline shape. Okay. And faster cooling rates produce the finer grain size. Faster cooling rate produces the finer grain size, and slow cooling rate produces the coarse grain size. Okay. Faster cooling rate produces the finer grain size. That is very important point. Faster cooling rate produces the finer grain size and slow cooling rate produces the coarse grain size to the particular solidified product. That is important curves, means cooling curves. What happens? Already I have told, undercooling means the temperature to which liquid metal must cool below the equilibrium freezing temperature. Undercooling means the temperature, that is the equilibrium temperature. That point shows the equilibrium temperature. Okay. Means the temperature to which liquid metal must cool, the liquid metal means the molten material cool below the equilibrium freezing temperature, and below that point the solidification will start, and below that point, below the equilibrium freezing temperature, solidification will start. Recalcitrance means the increase in temperature of an undercooled liquid metal as a result of the liberation of the heat during nucleation. Means recalcitrance means the increase in temperature of an undercooled liquid metal, means what happens as a consequence or as a result? What happens means the liberation of the heat during nucleation, means heat will be released, means heat will be extracted from the casting product and then it will start the nucleation, means below the equilibrium freezing temperature nucleation will be started, means grain formation will start it. Thermal arrest, only this zone is called thermal arrest, means that is the constant line, constant temperature line. Means what happens now, a plate on the cooling curve during the solidification of a material caused by the evolution of the latent heat fusion during solidification, means change of phase of the substance, it will be done by the latent heat. Latent heat is used for change of the phase of the substance, okay, and sensible heat is used to increase the temperature of the substance, okay. Latent heat will be used for change of the phase of the substance, okay. That line is called thermal arrest, that is the constant temperature line, means that is called thermal arrest, that part is called thermal arrest, okay. And that is the total solidification time, means that is called total solidification time, that is called total solidification time, means when pouring the molten material to the mold cavity, from that point to when it will start the solidification, means just start the formation of the grains, means that is called total solidification time, means the time required the casting to solidify completely after the casting has been poured, means when pouring the molten material to the mold cavity, up from that time when it will start the solidification, means it start the formation of the grain, that is called total solidification time. Local solidification time means the time required for a particular location in a casting to solidify once nucleation has begun, means that is the local solidification time. That is the local solidification time. It is also constant temperature line, and it is upper portion is called, that is the thermal arrest, okay, and that is the local solidification time, means up to that point, means that point means up to equilibrium freezing temperature, means after that point the nucleation will be started. That is the one important formula, prediction of the solidification of the time, means that will be dictated by, that is invented by Conniff's rule, means what happens, ability to remove heat from a casting is related to surface area, means one surface area is there through which the heat will be extracted from the casting process, okay, and heat is removed and the environment, that is rejecting heat to the environment, means from heat will be rejected from the pouring molten metal to surface, then surface to it will rejected to the environment, okay. So as per Conniff's rule, Ts equals to B into V by A whole to the power n, that is the Conniff's rule, where n is varies from 1.5 to 2.0 and Ts is the solidification time. Ts is the solidification time. B is a molding constant. B is a molding constant. A means volume of, B means volume of the casting. A means area of the casting. Okay. That is the important formula for casting. Okay. Directional solidification and cooling. In case of directional solidification, we have divided. For directional solidification, we have used the chills. As per use of chills, it will be used for directional solidification, means it will help to remove the heat from the molten metal to the surface, and from the surface it will heat rejected to the environment. Means two types of chills are there. One is internal chills, means small metal parts placed inside the mold cavity, means that is the B, that is the internal chills. Means here one chill will be added to that particular inside of that particular cavity. Inside of the particular cavity. Here we put the chills, means that is the internal chills. That is the internal chills. We have the chills will be placed to the inside of the cavity, means, and due to use of that chills, what happens, now more heat will be extracted from that particular surface. Heat will be extracted from that particular surface. More heat will be extracted particular surface than other surfaces. Okay. Means small parts, metal parts placed inside the cavity before pouring, so that molten metal will solidify fast around that parts. Means where we place the chills, means particular heat extraction takes place to that particular place. Means that is called internal chills. Okay. Another is external chills. External chills means here that is the, here we place the external chills, means externally we have placed. Okay. So in that cases, here we place the internal chills, and here heat will be extracted more from that particular surface. More heat will be extracted from that particular surface, means the place of external chills to that particular area. Okay. Means externally we have placed the chills. That is the external chills. Chills is used for directional solidifications, means it will remove the more heat from that particular surface. Types of solidification. Types of solidification means first is directional solidification, another is progressive solidification. Directional solidification means that occurs from the farthest end to the casting and works towards the sprue, means it will start from the surface, then it will go to the sprue. Okay. Another is progressive solidification. Progressive solidification means it will start the solidification from that particular surface. From that particular surface. Means what happens? Means that start at the walls. It will start from the walls. Start from the walls means more heat will be extracted from that particular wall surface. Means it will take the solidification. Means the removal of the heat from the walls, it is at like perpendicular. Okay. Means progressive perpendicularly from that particular surface. Means from that particular surface it will start the heat extraction, and that heat extraction as per perpendicular. We are consider the heat extraction from that surface, that is a perpendicular. Okay. That is the progressive solidification. That is the directional solidification, and that is the perpendicular, means perpendicularly heat will be extracted from the surface, and that is the progressive solidification. After solidification to the mold cavity, so what regions or what zones created to that particular casting product? What first is three distinct zones or regions we have each produced to that particular solidified product. First is chill zone. Chill zone means rapid nucleation that occurs when the molten metal comes into contact with the cold walls of the mold. Means when pouring the molten metal and it will comes to the contact surface of the mold, and in that particular surface the solidification will start. Means nucleation will be started. Okay. Another forms a narrow band randomly oriented crystals on the surface of the casting. Means one narrow band will be narrow solidification zone or solidified zone will be created across the surface. Narrow zone will be created across the surface of the mold surface. If we consider that is the mold surface, a narrow band zone will be created across the mold surface. A narrow band zone will be created across the mold surface. Okay. If we consider that is the mold surface. Mold surface. Then second is columnar zone. Columnar zone means rapid growth perpendicular to the casting surface. Means perpendicular type surface will be created. Means perpendicular rapid growth perpendicular to the casting surface. Means that is columnar zone. Means perpendicular structure will be formed. Another is highly directional, means all the formation of the columnar zone, that is highly directional, and that columnar zone, that is the long and thin. Every structure is long and thin. Third is equiax zone, means here crystal in the interior of the casting, means that zone, equiax zone, will be created interior surface of the solidified zone. Okay, and that shape may be spherical or randomly oriented crystals. Randomly means that is the crystalline structure may be formed to that particular solidified product. So you see this picture, that is the one example of the solidified structure of the casting product. Means if we consider that is the mold surface, that surface is the mold surface, that is the mold surface, that surface is the mold surface. That is the mold surface, and across the mold surface first heat will be extracted from the mold surface, and that type of narrow band zone will be produced. Narrow zone will be produced, means that is called chill zone. Okay, first is chill zone will be formed, then perpendicular shape, means that is highly directional, means long and thin zone, means that zone is called columnar zone. That zone is called columnar zone. That zone is called columnar zone, means that zone is called columnar zone. Okay, and internal means that crystal structure is highly directional, means that is orientally directional. That zone is called equiax zone. Okay, that zone is called equiax zone. Equiax zone. Zone is called equiax zone. And some upper surface, if we shown that upper surface, it is not straight line. It is not straight line. Means in that particular zone it will shrinkage. Means after solidification it will take shrinkage. It will take the shrinkage. Means that type of surface will be formed. Means it is not straight line. Okay. That is the three distinct zones in case of solidified product. Some real example of the three casting of the solidified zone. Now cast structure, that is the original cast structure. If we shown in that particular picture, example of the cast metal, actually that is the 443 aluminum cast. Okay, so that surface, if we consider that is the mold surface, so across this surface, that is the narrow band zone. That is called narrow band zone. That is called chill zone. Okay, and that zone is the columnar zone, and middle portion is the equiax zone, and that is the middle zone is the equiax zone. That is the example of the 443 aluminum cast. Okay, so if we comparison of the different process, sand cast, the yield strength near about 8 ksi, tensile strength 19, and elongation is 8%. In case of permanent mold, yield strength is 9 ksi and tensile strength is 23 ksi, and elongation is 10%. In case of die cast, 16 yield strength and 33 tensile strength, and elongation is 9%. So it will the practical example of the 443 aluminum cast. That is the practical example of the structure of the solidified product. Molten metal problems. What are the problems? What type of problems will be occurring? Mean some chemical reactions may be occur to that particular molten material. One of the main problem may be oxide will be formed to the molten material. Sometimes some molten materials reacted with the oxygen, and due to reaction with the oxygen, some oxide will be formed, and due to formation of the oxide, maybe it will rusting takes place, and due to formation of the rusting, the quality of the cast product it will be deteriorated. So sometimes dross means the presence of the solid impurities, and slag some presence of the solid impurities and presence of slag in the material that can be carried out with the molten material during pouring and filling of the mold. Due to presence of any impurities, slag to the particular mold cavity, the produced product is not good quality product, because due to presence of that impurities, the strength of the product will be reduced, and the presence of gas porosity also sometimes reduce the quality of the product and also reduces the strength of that particular product. Okay, that is the molten metal main and basic problems of the molten material. Already I have told different gas porosity problem means gas that is not ejected from the liquid metal may be trapped upon the solidification. If trapped to that particular mold surface, so one void will be created to the particular product. If it will ejected or if it will removed from that particular molten material, so that void will be not created and particular solid product will be produced. Okay, several techniques to prevent the gas porosity. What are the techniques? First is prevent the gas from initially dissolving in the liquid. If gas is present, so sometimes we are trying to dissolving in the liquid. If it is not dissolved, melting can be done in a vacuum. Vacuum means there no gas or any type of gas is not present. Okay, so melting can be done in a vacuum position, and in that vacuum position no gas will be present there. Okay, another, melting can be done in environment with low solubility gases, means some gases is there but it has capability to low solubility gases. Okay, minimize the turbulence. Turbulence means when we pouring the molten material to that particular mold cavity, so you taken care it will not create the turbulence. If it will create the turbulence to that particular grating system, maybe sometimes some parts may be eroded. So you avoided the turbulence when pouring the molten material. Vacuum degassing removes the gas from the liquid before it is poured into the casting. Means sometimes vacuum degassing also remove the gas from the pouring molten materials. So main objective is to removal of the gas from that pouring molten metal when we pouring the molten metal to the mold cavity. Gas passing insert gases or reactive gases through the liquid metal. Okay, so we avoided that type of molten material. It will not react with the gases. Means it will react with the gases, so it will form some oxides that will be very harmful. Okay, to that particular producing the good quality product to the casting process. Fluidity and pouring temperature means what happens, metal should flow into all regions of the mold cavity and then solidify. Means every molten material must flow to the every space of the mold cavity. If it will not flow to the every section of the mold cavity, so it will does not produce the good quality product. Means if it is the, we taken a mold cavity shape, if we have taken that type of shape, if molten metal does not flow to the part in every position, it will not flow to every position. So what happens if it will not flow that particular positions? Means it will produces that gap in that particular positions. Means metal fluidity means the capability of that particular pouring material, it will flow in every section of the mold cavity shape, in every section of the mold cavity shape. Otherwise the quality product will not produced. And most important controlling factor is pouring temperature. Means you maintain, always you maintain a particular temperature at which the molten material has capability to flow in every sections. If below the pouring temperature, when you coming the molten material to that particular cavity shape, it will come that portion, it will take the solidification, it will take solidification. Means after that the molten material does not come to that particular sections. Means it will, that portion will be not filled by the molten material. So it is not a quality product. So you maintain that pouring temperature, it will flow the molten material to every section. It will flow to every section. Okay, that is the fluidity and pouring temperature. Molding sand, different casting, that is the most important part of the casting process. So what are the main properties of the molding sand? First, silica sand grains. Molding sand contains 80 to 90% silica. Mold sand 80 to 90% is silica. Okay, silica in the form of granular quartz. Okay, means itself it is called sand. Okay, the chief main constituent of the molding material, that is the silica, means that is called sand. Okay, it has most important properties, that is the refractoriness, chemical resistivity, permeability. That is the most important properties of the sand. Clay is defined as a natural earthy material. It will help us as a binding material to the silica. Okay, means earthy material that become plastic when mixed with water. Means as like it will sometimes act as a binding material. Moisture over water. Clay acquires its bonding action. Clay material acquires as a bonding action using in the presence of required amount of water. Due to presence of near about percentage 1.5 to 8%. Due to presence of the water or moistures, the clay acquires the bonding action. Okay. Additives, materials other than basic materials are also added to that molding materials for improving the existing properties of the molding sand. Okay, first is facing materials. Facing materials are used to get the smoother and cleaner surface to the casting process. Okay, facing materials are used to provide the smooth and good surface to that particular casting process. That is the use of facing materials. What are the examples of the facing materials? That is the silica floor used as a facing materials. That will be provide, or coal dust, that type of materials provide the good and smooth surface finish to the casting process. Another is cushion materials. Means when we burn the cushion materials, when molten metal is poured to the mold cavity, so thus gives rise to space for accommodating the expansion of the silica sand at the surface of the mold cavity. Means when we provide the molten material, it will create the space for accommodating the expansion of the silica sand at the surface of the mold cavity. As example, as a cushion materials, wood floor, cellulose and cereals, that are the use of cushion materials. Wood floor means it is the ground wood, means that is the wood particles. Okay, means that will be formed by the some other processes. Additives, what is the purpose of that particular molasses, cereals, ethylene glycol? That three additives used as a binding materials. That three materials used as a binding materials means enhancement of the bench life and resistance. Means bench life means it will increases the life of the silica sand. Okay, and also resistance to drying out, means that if presence of that materials, it will resist for resist against the drying capacity. Okay. Another iron oxide and silica floor use increase a hot strength development. Means the strength will be developed of the silica sand at hot conditions when we added that iron oxide and silica floor. Coal dust and silica floor is used for good surface finish of the casting. Okay. Cereals and sawdust is used for collapsibility. Collapsibility means when we separate the casting product from the molding box, so easily we collapse the molding sand materials. When we mix the cereals or sawdust to the sand particles, so easily it will collapse. And finally we have taken the casting product from the molding box. Okay. And also that materials, cereals and sawdust, that also resistance to expansion defects. Means due to mixing of that material, other materials will not expand it. Natural sand called is green sand, means it is present on moisture or water. Okay, means and that is called natural sand. What are the advantages of the natural sand? Means natural sand maintains moisture. Already I have told. Now in natural sand presents moisture. Okay, and easily available in our earth, means easily available in the market, and also the cost of that natural sand also less with respect to other materials. The time for mixing of the binding is also saved, means it is the moisture is present to the natural sand, so it is not required to mixing the other binding materials. No extra equipment is not required for mixing the other binding materials, because moisture is there, so it is naturally helps to binding with other materials. What are the disadvantages? It is less refractory. Refractory means it does not sustain with higher temperatures. Means when we heated the sand, the moisture will be removed. Then synthetic sands, because impurities are present to that particular natural sand. Number of impurities are present to the particular natural sands. Application: light casting, mechanized production casting, we use that natural sand. Synthetic sand means basically clay free high silica sands, means it is absence of the clay to that particular synthetic sands, means it is artificially we have prepared that synthetic sands. Naturally in the natural sand, moisture or clay or some impurities are present to that particular natural sand. What are the advantages? It will be used for steel casting, means heavily core casting we have used that synthetic sands. What are the advantages? High permeability and refractoriness, means permeability means when gas will be produced to that casting product, so finer silica sands, finer silica grains, and due to presence of finer silica grains, the voids will be created, and through that voids the gas will be easily removed from the casting process. Okay, and also refractoriness, means refractoriness in that cases it can sustain at higher temperature. That sand sustain at higher temperature, also withstand the higher temperature, because in that sand no impurities, no moisture is present at that particular synthetic sand. What are the disadvantages? That sand is more costly, because that sometimes it will prepare artificially, and it need extra time equipment meant to prepare the sand. Means already I have told artificially we have prepared that sand, means some extra equipments are there for preparing that type of sand, so it will costly and it will take more time for preparing that sand. Some special sands used for some special casting process. Some example: zircon sand. Zircon sand is zirconium silicate. That sand has low thermal expansion, high conductivity, greater density, high refractoriness, means that is specially I have prepared. Okay, and due to special preparation of that sand is used for particular use purpose, for particular application purpose, these sands used for bronze casting, alloy steel, chrome steel, manganese steel casting process. So specially this sand used for particular this casting process, because it is manually prepare that particular sand. Olivine sand is prepared from orthosilicate of iron and manganese. Okay, so it has high density, conductivity, refractoriness. It is used for non-ferrous and intricate, means complex type product we have produced using that olivine sand. Okay, another is chamoti sand, that will be produced by calcining high grade fire clay at about 11,000 degrees centigrade and crushing it to the required grain size, means that is specially prepared. What is the purpose? Now it will used for heavy steel casting. That chamoti sand will be used for heavy steel casting, means that sand will be prepared for special purpose. Another is chromite and chrome manganese sand. So it has high refractoriness, high density and high chilling powder. It will be used for chilling tendency is to be increased to control solidification, means that type of sand used for heat removal, for chilling purpose. Okay, and by chilling of that particular casting process we control the solidification. So every sand, zircon sand, olivine sand, chamoti sand and chromite and chrome manganesite sand, that type of every sand has different use. Green sand means foundry sand contain moisture, means already told in green sand must be present with moisture or may some percentage of water, means in that silica sand 18 to 30% of clay, okay, and having total water from 6 to 8%. Okay, means green sand means it contains water or moisture. Dry sands free from moisture. In case of dry sand, no moisture, no water is present. Okay, only sand particles are present. Okay, another loam sand are mixture of 50% of sand, 50% of clay. Okay, that is called loam sand. Okay, it will be used for larger casting process. Okay, as example, large cylinder paper rolls we have produced using loam sands. Facing sands forms to the face of the mold. Okay, it will help for preparation of the mouthar surface to the casting. Okay, facing sand forms the face of the mold. Okay, backing sand means which backups the facing sands. Backing sands means it is the sand, it will back up the facing sands to the casting process. Parting sands means sand employed at the faces of the pattern. At the faces means across the parting line. Faces of the pattern before molding is called parting sand. Sometimes parting sand is used to avoid the sticking of the green sand of the pattern. That parting sand also helps used to avoid the sticking. Okay, avoid the bonding of the green sand to the particular pattern. Okay, that is one of the most important thing in case of parting sand. Core sand means that sand used for making the cores. Core sand means that sand will be used for making the cores are called core sands. Okay, another system sands means in mechanical foundry we use the molding sands for preparing the casting, means it is employed so called system sand is used to fill up the whole flux. Okay, means where machine molding is employed a so called system sand is used to fill up the whole flux, and in mechanical sand preparation and handling units no facing sand here, no in mechanical operation no facing sand is we have used. System sand means here we use the sand in molding box for pouring the molten metal to the mold cavity and finally we produce the casting product. That is called system sands, means using system sand we fill up the total flux. Another properties of the molding sand, permeability means porosity, means already I have told when molten metal always contains a certain amount of dissolved gases, and molten metal when comes in the contact with the mold surface, some steam or water vapors will be created, and due to creation of the water vapors or steam, it wants to come out from the casting process, means it will searches some voids or some tracks, means through which it will come out to the outer surface. If they will get some voids, then it will come out and the produced product will be good product. If it will not come out from the casting, then it will produce the low quality, poor quality product. Means some void will be created, and due to creates of that voids, the strength of that product will be reduced. Plasticity and flowability means it will to acquire predetermined shape under pressure and retain the same when the pressure is removed. Means only sand materials, when we provide the pressure to the molding sand, and due to providing pressure, it will take the shape, means take the compact shape to the molding flux. Means it will, here the molding sand shape will not deteriorated. Molding sand material shape is not deteriorated or not changes. Means we giving the pressure to the molding sand, to the molding flux, it will take the particular shape of that particular flux. Okay, and after removal of the force, that particular sand possesses that shape. Means it will does not removed or does not deformed. Due to non-deformation, it will take the particular shape of the flux. Okay. Adhesiveness means molding sand particles should stick to the surface of the molding boxes. Means that is the attraction of the different particles. Attraction of the different particles. Okay. Means molding sand particles should stick to the surface of the molding box. That is the adhesiveness. And in case of cohesiveness, that is the attraction of the same particles. Means what happens? The ability of the sand particles to the stick to each other. Means ability of the sand particles sticks to each other, means attraction of the same particles. And adhesiveness means the ability of the sand particles stick to the surface of the molding box. Means attraction of the different particles. Green strength means it is the strength of the sand it will maintain in green conditions, means it has some moisture. Dry strength means it is the strength of the molding sand, it maintains its strength in dry condition. Okay. Another is hot strength, means it is the strength of the mold cavity. It is the strength of the mold cavity, it maintains above 100 degree centigrade. Means the strength of the mold cavity maintain above 100 degree centigrade. That is the green, that is the hot strength. Means green strength is different, dry strength is different, and hot strength is different thing. Another refractoriness means the capability of the molding sands, it maintain or it withstand the higher temperature easily during casting process. Means the capability of the molding sands to withstand the higher temperature of the molten metal without fusing. Means when we pouring the molten metal to the casting process, the shape will not changes. Means it can withstand the higher temperature easily. Okay. Another collapsibility is the property of the molding sand that permits it to collapse easily during its knocking out from the casting. Means after casting, we easily broken the molding sands and taken the finally the produced product easily. Means it has easy capability of the collapsibility. Another is coefficient of expansion. Molding sand should possesses low coefficient of expansion. If we provide the higher temperature, molding sand is not expanded. Means it has low coefficient of expansion capability. Fineness. Finer mold means finer grains of sand produces the fine casting product. Means what happens, finer mold sand resists the metal penetration and produces the smooth casting surface. Finer grains produces the smooth casting product. Another is bench line. Bench line means molding sand retains its properties during storing, handling and while standing. Means what happens, the molding sand does not deform or does not changes its shape under pressure. Means it will always follow the same shape and size under pressure when we storing, handling or giving the pressure. In that time its shapes it not changes. Chemical reactivity. The molding sand does not react with other materials. In general cases, the chemical reactivity is very less, very less. Means molding sand does not react with other materials. Steps. What are the steps in case of sand casting? Generally 5 steps. First is pattern making. Second is pattern, means we have produced the pattern. As per pattern shape we produce the mold cavity. Then core making. Core is used for producing the internal shape. Another is molding, means after using the pattern and core we produce the mold cavity to the flax. Another is melting and pouring. Melting and pouring means then after creating the mold cavity, then we makes the molten material. After creation of the molten material, then we pouring to that particular mold cavity. Okay. After pouring the mold cavity, the solidified product will be produced, and after production of the casting product, then finally we have taken from that molding box, and it will be cleaning, finishing and inspected to that particular casting product. 6 basic steps means pattern making, core making, molding, melting, and that is the 5th pouring, and that is the 6th cleaning, finishing and inspections. That is the basic materials, equipments for sand casting. First is pattern. Pattern means particular pattern we have produced, means we want to produce that type of shape. First is pattern 1. Second is sand. Sand is used for filling up that particular mold box. We have used the sand. And container of molten metal means after making the molten metal, then it will be carried out by the ladle. Okay. And ramming, to compact tool. Rammer is a tool. It will be used to compact the same sand to that particular mold cavity. Okay, that is the required parts for sand casting process. 1 pattern, 2 sand, 3 is container, 4 is rammer. And what basic summary of the sand casting process? First of all, mix the sand. Means that sand will be added to the particular additives. Okay, for our casting purpose. Then sand placed to the bottom mold, means drag part. Bottom will be placed to that particular sand part, drag part. Okay, sand placed into the bottom mold and form and compacted, and that particular sand will be compacted using rammer. And then first is molding. Sand placed into the bottom mold and formed and compacted. Second is molding. Pattern placed into the mold, means lower part in the drag part we place the pattern. That is the pattern. We place the pattern here. Okay, that is the drag part. Third thing, add the stop mold form. Means here that is the cope part, and that is the drag part. Then add the top mold form, means that is the cope part. Then we take the drag part and it kept to that particular drag part. Okay, and inside that molding box we kept the pattern. Okay. And a tube or pipe provides path to pour the metal, means a pipe we have placed here and through which we pour the molten material. Okay, and these two box we fixed using some pin. Okay, and fill top form with compact sand, and the upper part to the particular cope we fill up using the taking the particular sand. Then molding, take the top mold off and remove the pattern, pipe or boost. Means after formation of the mold cavity, we take off the top mold, and after that we taken the mold. Okay, we taken the mold and also remove the pipe also. Then again in the middle sand is cavity shaped. In that particular middle shape, the cavity will be formed as per pattern shape. Okay, after formation of that cavity, we remove the pipe and pattern. Okay, then that pouring hole will be created. Then pouring hole will be created to that particular mold box. Okay, replace the top mold and fasten securely. Means after formation of that molding part, means scope and drag part, properly securely we have fastened. Okay, then a copy of the pattern, then we pouring the molten material to that through that particular screw, and then molten material comes to that particular mold cavity, and after pouring the molten material, that type of product will be produced. After solidification or after production of that part, we remove the upper part. Means a copy of the pattern now has been made to that particular material. Then we remove that part. After removal of that part, then finally we have taken that particular pattern shape. Okay, and break apart the two halves of the mold and take out the part usually requires vibrating. Means some vibrating or striking given to that particular mold box, means it will take some looseness, and due to creation of the looseness, finally we have taken the mold part. And then sand is cleaned. Means after taking that part, then we clean the all surfaces. If some parts will be stick to that particular pattern surface, that some impurities will be cleaned by the some machining process. Okay, and finally we inspected, means the generated product is good or bad. Okay, means we measure the some dimensions and measure the some other dimensions, and we taking some other devices, means the shape is good or not, and then finally mold forms are reused. Again the process is continuing, and sand is broken up and screened to remove the debris and clumps and sent for remixing. Means some debris will be mixed to that particular sand, then we remove that debris and again we reused that sand. What are the advantages of the casting? Using that process we produce the different complex shapes. We produce that sands will be used for large type of casting processes, and parts, hollow type parts also we have produced use that casting process. Very large parts also produced. Intricate shapes, means complex shapes, also produced using that casting process. Another, different mold materials can be used, means sand, metal, ceramics, different materials also used for producing different shapes. Another, different pouring methods also there for producing the different casting products. Disadvantages: it gives poor surface finish. Most required surface finish operation is required. Means after preparation of that casting product, generally the surface is not good, so extra surface finishing operation is required. Second is, sometimes some defects will be involved in that process. Okay, means gas porosity problems, means some oxide problems will be occurred to that particular casting product, and sometimes it provides low fatigue strength compared to forging. Means in that produced product, if we giving the repeated loads, due to giving the repeated loads, the product will be deteriorated. Means it has low fatigue strength compared to forging process. Another is, It is not economical for mass production, means for production of one product it takes more time. So it is not economical for mass production. And applications, what are the application of the casting product? It will be used for automobile parts, for preparation of aerospace parts, for preparation of the shipping parts, farming parts, machine tools, preparation of machinery parts, electrical parts, energy parts, art parts, medical parts, home fitting, sanitary, defense. For preparation of the different parts, that process will be used. That is the typical metal cast we have prepared using that process. And after this, what is the concluding learning outcomes? After this lecture, end of this lecture, students have learned about the introduction to casting, requirements of the casting, step involved in the casting process, and advantages of the casting process, and also disadvantages of the casting process, and its application of the casting process.